Okay, I'm back to talk through a little bit more system design stuff, uh, just in terms of what I'm thinking through with this particular system before I actually get to the point of committing any code. And I would hope that the fact that I've been talking so long before writing anything will be a good indication of the fact that there is stuff to talk about, to think about, um, that is meaningful to do before you start getting any code down. So often it can be easy to change code if you're early in the process, but you don't want to get in a situation where you are late in the process and uh, and you've found that you've baked everything in. And in fact, the reason that this project exists is that I have another project which got too much code for me to improve. So it was easier to write it again from scratch with a better initial concept in my head, hence the word semantic here, um, and yeah, work from that. But rather foolishly, I wanted to get to a state where there was a proof of concept parsing before I had any of the concepts which would live behind it. Obviously, there's a it doesn't matter about whether you have the exact details down. So, for example, if I remembered that both abstract and final exist on symbols, that doesn't matter. I could have thought that they don't exist, or maybe that just one of them existed, and still had a design that's workable. Because if I had the design into which the missing concept would fit, that would be no problem. That would work. So the time when it doesn't work is if I'm just thinking, oh yes, I'm just going to type up if it starts with a dollar sign, it is this, um, and then not really think any further, because that's the kind of situation where you would come back later on and say, oh wait, I need this to be asynchronous. I need this to have flags and properties. So it's yeah, it's something that's worth dealing with. So previously, I was just looking at the top level. So a key reason that I was talking about asynchronous stuff previously is that a lot of the resolution of stuff, of class names, for example, um, can't be done before you well, so yeah, so a lot of, so resolution of return values, for example, may be impossible to do until you have resolved everything that is in the code that is producing the return value. And in order to do that, you need to parse the things that are referred to in the code, and that means you need to be asynchronous anyway. In particular, a key thing with this is that if you have a method and it doesn't have if a method has an explicit return type, then hooray, there's no problem. And in fact, so I have previously thought this through. So in terms of methods with return types, it the way that a parser should ideally handle it is that you would take the prototype version, the one that's actually in the code, um, and if there isn't one of those, you take the documented one, the at return value, and if there isn't one of those, you take whatever the code does. And that's the thing that last one is the situation that's most likely to be relevant to PHP. If you are looking directly at it, well, which is kind of a funny concept to be giving here, but so this is a parser for the purpose of doing syntax checking. So, rather for the purpose of doing linting. So for this purpose, I don't really care too much if an included if an included class is valid or not, I'll just assume that it does what it says on the tin, if it has a tin, that is. As soon as I reach the point where I can actually understand what it does, what it returns, for those, I'm happy. That's fine. But for cases where you are looking directly at the file, where the actual contents of the file are relevant, I will still nonetheless want to be looking at the content of a method to validate that it does return what it claims to return. So there'll be a separate concept here of whether a method, or I suppose a class symbol in some sense, whether it's valid, which will be separate from the concept of what type it has. So here, this thing is currently, I know it says value, it's not a value, it's one of these parser states. This is going to have to end up being a type. So this is going to have to end up being a type coupled with a validator. So it'll have to have those two properties. Sometimes the code will, circumstantially dependent, the code may attempt to evaluate what's inside a method, and it may not do that. That's basically the situation here. So we're going to have, as well as abstract and final, we'll have a validator, and inevitably, so this, there will be a name attached to this. You can see that I've actually got a handler for names, and here I've got a little bit more abstraction than I'll really need in the final semantic version. But what the name is doesn't matter to the symbol, it matters to the class. So this will, in the end, produce a value which doesn't inherently have a name, but it will be attached to the class with a name, which will be relevant to how the class is constructed. So the class will have the class namespace. So yes, that's this thing here. This will have a map of things. In fact, it will have multiple maps, because that will be easiest to do. And specifically, so I know from having done very similar implementation of this, I know that I'll want to have static namespaces for each of the protection levels. So private static, protected static, public static, or the other way around if you really prefer, but the convention is to do it that way around. And the same for the same for instance namespaces. So I'll have private, protected, and public of those. And although I'm saying the word map in this, in practice, it will be multiple maps, because where you have the protected and public symbols, they may include some degree of inheritance from other classes, and those should be directly referenced. So in other words, if you're doing a lookup in private context, you would look for private symbols that are local. Then you would look for protected symbols which are local and public symbols which are local. Then you would look in superclass for protected and public symbols that are local to it, and so on down the tree. So we'll have inevitably a lookup method in this, which which will have to be an asynchronous one, most likely, and that will produce the value which you want to have in the end. So async may sound like it's a little bit of a scary thing, but you can say that a method is async and have it not be async. That's perfectly fine. That will work. I mean, it will work a little bit differently because it will yield the execution context and then return to it, which has some relevance if you're working in an environment where multiple things are changing what's in the namespace, so like in a browser context. But for Node, it's less of a problem. It can be a problem if you're doing it at particularly high frequency, but that's something that you would just deal with. But in essence, a key thing to remember is that it's always okay to write an async function and then convert it to non-async if it turns out that it is not actually async. That's an easier thing to do than to take a sync function and make it async later on. Because again, so callers can use await on a thing which returns an immediate value. That is fine. That will never cause a problem. So in general, better to start with async anyway. So here I'm going to have a name which will have to be available to the class body, and I will have a type which will be relevant to which will be relevant to the class and to things which are using the class. I'll have to have validator. That can be called in contexts where it's relevant to be doing validation. And so at the moment, this does have the word value in it. That's not for completely ridiculous reasons. It is sometimes of relevance in terms of compilation to know specifically what the thing is that you're looking at. So to know not only just its type, but what its value is if it has a value. So for example, if you have a constant in PHP, a constant is mapped to a single primitive value, I believe. So not an array. It would just be a number or a string or null or true or false, I believe. So it's very simple values. And it's relevant to know what the constant value is, because if some idiot is testing it against its underlying value, then yeah, you want to be able to say, I know what this does. In particular, you might want to be able to say, I know this won't work, because you're testing a constant against a value which it does not have, so this code will never execute. And there may be some relevance to considerations which are related to that, like whether constants appear in a certain order. But mostly for constants themselves, the value won't be very important. And for variables, it's of more relevance that they initially have a value or they initially do not have a value than what that value is. So that, in other words, the initial type of the value may be a thing that may be of relevance. And for this specific purpose, I would express the so for this specific purpose, I would express how the initial value is written, most likely by using a type expression with a value on it. So that will make it easier to compare what it initially is in terms of looking at the constructor, which is a very relevant thing to this. So something to bear in mind about the specifics of how PHP works are that inline definitions of properties can only use a subset of PHP syntax. They can only perform it can only be an immediate returnable value. It may not be any form of a compound expression, which means that you can have a default assignment to an array. That's fine, and that array can have contents on it which are perhaps quite complicated and quite long, but it still needs to be an array that can be expressed as a value at the time of compilation, not at runtime. Even if you know what the type is, it still needs to actually be a value which can be determined at compilation time, not at runtime. And that excludes things like mathematics and string concatenation. So, yes, they're a special little thing, and that will be somewhat of interest to this. So, yes, here I'm thinking this will have a type, it'll have a validator, and it will have some expression of an initial value which is likely to be a type and may, in addition, contain the underlying value. I will say that a concern that I have with these things is over-engineering. It's completely possible to implement a beautiful, complicated feature that is just useless. And here, retaining the value may be one of those useless things to do. It may be that knowing specifically that the constant curl underscore multi underscore select is has the value 3. I mean, it doesn't have the value. That's not a constant, but I'm giving you an example of what it might sound like. Knowing that specific thing may be unhelpful for performing a semantic analysis, because of course the specific determination that it has the value 3 is down to how it is implemented in the current version. So normally, in fact, I won't even say normally, always, people should be using libraries or using just any code that they have access to. It should be used based on its documentation, not based on its implementation. So a lot of the time, people like to think, oh, I don't quite know what this does. I'm going to look at the implementation, and then I'm going to write code based on that. And the problem is when they do that, nobody knows they've done that. Nobody even knows to expect that that's the case, because the next person to come along and do an update to it would just look at the documentation and think, okay, this change I'm going to make is consistent with the documentation, and they would go ahead with that. Strictly speaking, so a lot of the time you would look at the documentation as being the true implementation of the code. As crazy as that might seem, the documentation, I mean, look, I'm giving this example with virtually no documentation here, which is very ironic. But yes, the documentation is a lot of the time the truest definition of what the code does. So if the code and the documentation disagree, as a general rule, the documentation is right and the code needs to be fixed. That includes if somebody has discovered that the documentation is inconsistent with the behavior and is now dependent on undocumented behavior. You want to be dealing with it as the documentation is true, the implementation is false, as far as that stuff's concerned. But there can be cases where the documentation is essentially wrong. In other words, where the documentation perhaps contradicts itself, or where the documentation contradicts the intent of what the thing does. And if that's the case, if the documentation does a thing which is opposed to the design, whether it's written down or not, and the implementation does something which supports the design, then that would be a time where you would be talking about correcting the documentation. But where that's the case, you do need to give a little bit of consideration to whether people need to be informed that the documentation was always incorrect. Obviously, it's possible that the documentation was incorrect and the code was incorrect. And in that situation, you are kind of in the horrible position of having to probably do a version bump, or into like a minor version bump, or whatever the next step is above what you would normally do, or to communicate with literally everybody who's using it that they've been doing it wrong the whole time, and it's going to change. And possibly you may need to do both of those things. And a third possibility is that you may need to provide an extra implementation which operates sanely and deprecate the original one, which in itself is nightmarish. If you have, if you're ever thinking of doing deprecation, if you can avoid it, don't do that. just don't do that, because you're never gonna get anybody. Well, you will get some people. You're never going to get everybody to stop using deprecated code. People don't stop using stuff until it breaks. Just no matter what the stuff is, they don't stop using it until it breaks. And then when it breaks, it's suddenly urgent. So, yes, that's just the way of life. That's how life is. So, yes, deprecation. It's something that you need to manage a lot. You need to be actively listing that stuff. You need to be giving timelines for when it's going to get removed. Yeah, there's so much that you need to do. It's mostly not worth it. Get it right in the first place if you can. So, right, getting back to what I was actually. How did I get into deprecation? How did that happen? I don't even really know. So okay, so yes, well, so we've got these values which are the underlying types. So here I'm not going to be so that the difference between a variable and a constant won't actually make a difference to what the type is. So this won't be a distinction which really exists, but these are actually going to end up emitting names and corresponding values. So in that sense, that's going to be less of a problem. And the functions obviously are going to do their own stuff. Interestingly, abstract functions, of course, are a case where you do not have a function body to work with. Although, so subclasses, a non-abstract subclass will have a function body to work with. So this is a case where the specific handling of this is of relevance. So the actual PHP parser won't care. It's it's a thing. I guess that's how I would say it. It's a thing. So the PHP parser does care about whether there are abstract functions defined. It does care about whether the types match. But of course, it doesn't really have a reason to care about the implementation apart from the one that is being called. There's no reason for it to care about anything else. So everything else will be parsed syntactically, but there's no reason why it would care about anything that's in the subclass until the subclass version is called. So from that perspective, obviously PHP never has to deal with the matter of whether an abstract function returns a type, and if it does return a type, whether that type is essentially contradicted by anything else which is in the abstract class, because it's only actually ever going to be called in the subclass. So that's something which is not of relevance to it. So, but for the purpose of doing the type checking, an abstract function is one which only contains a prototype and documentation. It does not contain an implementation, so it cannot be validated, for one, and in cases where the documentation does not include @return and the prototype does not have a return type, and equivalently the same for arguments, although arguments are a different concept entirely, there will not be the possibility to move on to examining the body for that. It will just have those two types. Most likely for this, as I do the design in my head, thank you email, I will actually implement this as still having validation in the same sense that a non-abstract function would have validation, but I will limit the validation to just checking that the documentation matches the prototype. So it will still be a thing which has a type, and it will still be a thing which has a validator. It won't be a thing which has a value, of course. Yes, that's how it will be. And actually, this is worth covering at this point. So, although these values, these two list values will of course expand to multiple things, which is a little bit of an annoyance. That probably actually indicates that that this needs to be further broken down, because I don't really want to have a class symbol that's that's built as abstract or final in that sense. Well, actually, yes. So yeah, look at this. This will need to be broken down a bit, because in fact I don't want to have abstract and final branching into constant handling or into variable handling, because you can't have those keywords on those things. So most likely those two will want to change into going into a more specific parser method thing, and having that do a reparse. In fact, we don't have method at the moment, but that will be a thing I can add. So yes, although these return, these have lists at the moment. That really just means that there will be a list of things to do at a higher level, and those for at the earliest point should just be attached to the higher level with a promise, not really with anything else, and just left as they are. So yes, each of these things will certainly have a type, and I'm pausing after that because these last two things do not have a value. They don't have a value that makes sense. If it were in JavaScript land, they would have a value that kind of makes sense. But in the PHP land, they don't. You can't pass. Well, okay, no, strictly you can. You can pass a function around, kind of, but you aren't passing the function. You're passing a reference to the function in PHP. So it's a different concept altogether. So what I'll actually have is I'll have types which can have a value and types which cannot have a value. And in either case, yes, in either case they should be validatable. So, for example, if you have if you have a value which has an immediate assignment, so if you have a property which has an immediate assignment and it's documented one way, then it will be of relevance to validate it because it may actually be implemented a different way. So it will still be validatable, but it will conditionally have an actual meaningful value. In the specific case of properties, not in the case of constants, a little bit annoyingly, I know that they will initially not be defined, but that may be a state which is used. So properties will be they will be symbols which have got values, even if they do not have a value assignment, but that value will not initially be set. And in fact, possibly, I may express that as the value undefined in JavaScript sense. Okay, so I've talked for about half an hour. I'm kind of ready to start dealing with having the class namespace, and yes, that's talking through some system design. Thank you for watching.